Hi everyone, welcome back to the channel. On today's video, we are going to continue from our Docker container series, and today we are looking at Docker Compose. In our previous lessons, we've looked at how to Dockerize an HTML file, and then also we looked at how to Dockerize a Python application. If you haven't watched the videos yet, you can go to my YouTube channel and you can see this is the part 2 of the Docker Compose video where we discuss how to Dockerize a Python application. We also look at the part 1 where we looked at Dockerizing an HTML application. And so if you haven't watched the videos yet, you can watch both the part 1 and part 2 before you come to the part 3. And also, if you haven't subscribed to my channel, kindly subscribe to the channel. Let's move this channel to 1K subscribers. Without further ado, I will move into the tutorial section. Like I mentioned earlier, we're going to look at using Docker Compose to run multiple application services if you are not doing the Kubernetes stuff. And so today we are going to create another folder in our project directory. So we name this folder compose-demo. Okay, so this is our demo folder. So in this demo folder, we are going to create 2 folders, one for front end and then one for back end. So we are going to create a simple web application whereby we will create tasks for the day and then save those tasks in a backend database so that even though our containers get restarted and get recreated, this tasks that we created or this data will still be saved in the database. And so that's what we are going to work on today. It's a simple web application, and then we will learn how to use Docker Compose to spin up all these 3 containers. So we create our first folder, which is front end, and then our second folder, which is so that will be backend. Okay, so we'll start with the backend. We are going to create a Node.js server, a simple Node.js server with some API endpoint that we will use to connect to the front end to also be able to integrate that API endpoint into the front end to be able to make queries on the database. So let me create a file in the backend directory and name it server.js. Okay, so we are going to create a simple web application like I mentioned earlier. So first of all, what we need to do is that we are going to import some requirements. We are going to import some requirements that we need to spin up the web application. Okay, so we are using Node.js in this regard. We are not going to install Node.js or anything. We are just going to import some libraries and then also spin up the server, build the application with Docker Compose. So let's import those libraries. So import required Node.js libraries. So the first one, we are going to import const express required. So we are requiring an express library. Okay, that will need in this regard. So this is it. And then we hit the semicolon. Okay. We will also need Mongoose for we are going to use MongoDB as our database for the backend. So we are going to use Mongoose for that as well. So we import Mongoose. And then the other library, Node.js library that will require is a course. So we are going to import that library as well. Okay. In this. Okay, so now that we import course, Mongoose, and then Express, the next thing that we need to do is to oh, I thought I import course. Okay, so we've now successfully import course. The next thing that we need to do is to create the Express application instance. So we are going to initialize this instance. Okay. And so this is how you initialize Express application instance. So const app equal to Express. Remember, we imported the library, so now we are going to make use of that library, okay, to initialize our application instance. And this is what we've just done. The next thing that we need to do, we are going to create an app that will essentially use the course that we create so that the front end can make an API call. So we will term this as a middleware. So it will be a middleware. So middleware to enable course so that front end can call this API. Okay. So we say app dot use course, and then we open and close. So this is how you enable course so that the front end can use it to make API call. Okay, so now that we've enabled the course, the next thing that we need to do is to connect our database. That's our Mongoose database that we are going to use, which is the library. This is the library here. So we need to also connect our database to MongoDB. And we are going to do that using the Mongoose library that we imported. Okay. So we can say connect to MongoDB using Mongoose. So basically the code block mongoose dot connect, we open and close brackets, and we're going to pass this as a string. So MongoDB Mongo. So we pass the port, which is 227 2701, and we are going to pass that to my app because we'll name the application my app. Okay. So now we can create schemas to pass certain, basically what we are doing is to use the Mongo service name for the Docker Compose. That's what we are going to build. Now that we've connected to the MongoDB database using the Mongoose library, we need to define certain parameters that we'll use to create tags for this application. So we'll use this for new URL as a new URL. We'll use this as a new URL parser. So this will be a new URL parser. And then we'll use this for connection management as a connection management agent for the database, the MongoDB database. All right. So now that we've connected to our database, the next thing that we need to do is to define Mongoose schema. Okay, because we'll be accepting user input, we need to define a schema, and so define a Mongoose schema for tags. Remember, I said the application will be a tags application whereby you'll be able to create tasks that you will be performing within a particular time or a day or a month. So we're going to define those schemas. So we will need a title, and which that will be a string. And then we will also need a completed, if the task is completed or not. So we need the task completed as well. So we'll set that as a Boolean. Okay. So now that we define the schema model, we need to define our API route. So the API route to make the request to the backend. Okay. So this is our API route. Yes, so we are going to pass that as a JSON file. So we'll basically find all the tags in the database. This will find all the tags in the database and then send that tags as a JSON response from the database. So the next thing that we need to do is to also define an API route to create new tags. So this will get the tags. Now we want to create new tags. Okay. So we have app.posts. I think this, let me see this. So I hate autocomplete. Okay. So let's write this on our own. So we have slash API. This is supposed to be API and not app. Yeah. Okay. So API slash tags. We've closed that already. So we have async requests to const tags equal to new tags. Okay. So now we are calling this tags that we created. So const tags equal to new tags. Then we'll have a request.body and then await tags and then what's saved. And the response will be a JSON tags. Okay. So finally, we would start our server. So start server on port. We're going to use port 3001. Okay. So let's app.listen port 3001. So right there, yes, we are console logging this in the console. And I think that should be so. Our API is done for the server. Next thing that we need to do is to, because we are not installing any package manager, I have already prepared a package.json file that we'll be using. So let me just create that file, package.json. So I'm just gonna paste the package.json file that I created, content. So this will be our content. If we are not installing anything, the next thing that we need to do is to create our Docker file so that we can Dockerize the backend. Okay. So what we are going to do in a Docker file, we are going to import the base image that we will need to build the application, and then we'll create a working directory, copy the package.json file, and then run npm install so that we can install all the application dependency for the backend. And then also we'll copy the entire code and then finally expose port 3001 in a Docker file and then run the command node server.js to start our application. So let's do that now. So the instruction from node 18, so we are using node 18 Alpine. That will be our base image. Let me comment this. It's important to always write comments in code. So use Node.js version 18 on Alpine Linux as the base image. So that's what we are using. The next thing that we do is to create a working directory. So we say set the working directory, and then we can term that as so we can work directory. So you're going to set the work directory as app. Okay. And then next, we are going to copy the package.json file. So we can just do this. And then also install npm dependencies for the application. So run npm install. We'll also now copy all the files for the rest of the application. So you can do copy dot. So that will actually copy all the application files, which include this, and this, to the app directory in the container. And then the next thing, we've already looked at Dockerizing applications. We've learned about Docker files and all of that. That's why I'm moving this a little bit faster, because today's lesson, the focus is on Docker Compose. So I'll take my time to read the Docker Compose file so that you get an understanding of that. So we are going to expose port 3001 for the application. So the backend container will be running on this port. All right. And then finally, we'll start our application. So that will be npm. You shouldn't even use npm, but we are not installing any pack, so we'll use node instead. And then we are going to use the application server, which is server.js. So we are referencing this file in the command to start our. So that's all we need to do for the backend. So we first created a simple backend, and then we also created a simple package.json file, and then the Docker file itself for Dockerizing the application. Next thing that we need to do is to work on the front end. So in the front end, just like we did for the backend, we are going to create two files. One will be the index file, index.html, HTML file, and then the other one will be the Docker file. So we are going to use the same index.html file, but this time around I've already prepared this file, but this time around what we are going to do is to call the application, that's the backend endpoint in the front end, so that we can use that to query data from the server. So I've already prepared the index.html file. I'm just going to copy it and paste. I don't want this video to be long because we've done most of these things already. The focus is on Docker Compose. So I'm just going to do a quick walkthrough of what we are doing here. So there's our front end. We created this HTML file. So the title is a task manager. We've also created some placeholders to create tags. I remember we are creating tags, so we created this button that on click you should add a new task. And now we are calling the backend API endpoint, which is localhost 3001/API. And then we created a function to fetch and display all the tags. So this is the function that we created, and we are calling the API endpoint, which will be what tags. So we'll list all the tags that's using document get elements by ID, that's the tags list. And yeah, so I think that's basically what we are doing in this particular front-end file. Nothing fancy. So remember we created this demo and we use this Docker file. We are essentially going to use the same Docker file. We are not going to change anything in this file. Yeah, so that's about that. So everything that we need to do for the front end is done. Now that we are done with the back end and then the front end, we'll create our Docker Compose file at the root of the Compose demo. So we say docker dash compose.yaml and then hit enter. So we're going to create a YAML file which will define all services that we need for the application to build and run. So this is a full stack application. So let's start by writing a comment. So here we are defining all the services, in other words, the containers. Okay, all the services in our application. So first we define service. So we define the services, and the first one, let's write a comment and name it as let's say service 1, which will be our database. So we can say Mongo, let me write this in lowercase, MongoDB database. So we are defining a service, a container service for our MongoDB database. So we'll name this as Mongo, and then we define the image, which will be Mongo 6. That's the image. Oh, sorry, I need to indent this. Yeah, indentation is key when it comes to these YAML files. Incorrect. Expected object. Which object are you referencing? Think this. Yeah. So we need to be very mindful with our indentation. And the next is to define volume. So we looked at volumes. Now, because we are storing data, it is important that you define a volume where you store your data on the container for persistence. Okay, so in case the container life cycle happens, that's it gets recreated, this data will persist so that the new container that will be created will still make use of the data that already exists on the previous Docker container. So we are going to create volume, and that would be Mongo. So we can use this directory for our database volume. Okay, so that would be Mongo dash data, and then what? DB. And then next is to define, we are not going to define any port. Well, what we would only define is the network, because the container needs to join other containers. So we define the network. And we can name this as app network. Okay. And so now that we've finished with so what happened here is that in our Docker file, we created our first service, and in this service, we defined the MongoDB image that we'll be using. That's Mongo 6. That's the version, and then we define a volume. So what we are trying to do here is to mount a named volume to persist the database data. So we'll be entering some tags, and we'll be saving that tags on the database. So what we are trying to do here within the container, the backend container, we want to persist that data so that at every point in time when the backend container get created, that data will still be made available for the new container to use. And so that's what we are trying to do here. So we want to persist that data inside the container. And so we define the volume, and then we also define the network. Okay. So next is to create our second service. So service 2, which will be our backend. So we define this service as backend. Let me check. Okay, I need to align this properly. Okay. So we are going to build this. We are going to build this on the when the Docker Compose is run. So we are going to build this when Docker Compose runs. So we are going to reference the backend file to build this particular service. So we'll do that via the root directory. And then we'll also define the port, because we want the application to have a port. So we are going to use ports. Let's see. We're going to use ports. Yeah, we've already defined the port, which will be port 3001. But then we need to map it to the host port, which will still map it to port 3001. So this is our application port. Okay. What's going on? Okay, next is we need to specify that this particular service depends on the database. So when Docker Compose is initialized to build the services or the containers, what will happen is that it will first of all wait for this particular service to be created and stable. Then the backend service will be what created as well. So we are going to define this as depends on. So this will depend on the Mongo service, which is this service. I don't know why this is. Let me try and rewrite this. Okay. Oh, I made a spelling mistake. So it's supposed to be pot, not pot. Okay. So we mentioned, or as part of the instructions, we mentioned that this particular service depends on this service. So when the containers are being built, this container will be built, and then once it starts running and stable, then this will essentially be also created as well, because we specify this rule here that this particular service depends on this. Okay, so that's our service. So we need to also define network, which will also be the app network. So it will depend on the app network. And we need to set an environment variable as well. And let's put the environment variable in this session. So the environment variable will probably be a node. So you can say environment variable so node env production. So we are just specifying this to help us to be able to build the application. Yeah. So this is, I think it's a Node.js requirement or something. Yeah. So now that we've defined our network, still not sure why this is lagging. And this is not aligned. Okay. All right. So we are done with our backend service. The next service that we create is the front end, which will be our service, third service, and we name it as the front end. We are also building it and referencing the front end file, which is this one, front end folder. All right. So just like we did for the backend, we also defined the port number for the front end. And this time around, we are defining ports 8080, and then we'll map it to, so the front end port is port 8080, and we are mapping that to the Nginx because we're running the application on Nginx server. We want to map that to the Nginx port, which is port 80. So if you look at the front end Docker file, we are exposing port what 80. So we want to map that to the Nginx ports. So these applications. So whenever you hit the Nginx ports, the traffic will be redirected to this particular port. All right. And we also need to ensure that the front end container depends on the backend. So the backend will be built, and once that is done, the front end container will also be built. So we need to define depends on the backend. We define the network, which is the app network. So this is what we need to do for the front end service as well. So we've defined how many services so far. We have the Mongo service, we have the backend service, and then also we have the front end service. So since we in Docker Compose, when you define a volume, you need to specify the volume. Okay, so the defining volume to persist the data, we need to create a new volume such as Mongo data, and that is the volume that the backend will use. So Docker essentially manages this volume to persist data. Like I mentioned, even if the container gets deleted, this volume gets made available to the new container that will be created. So we need to define that volume. It's a Docker Compose requirement. So even though we define the volume, we need to specify that volume with a name. And so remember, we give it a name as Mongo data. So we need to specify that volume, and then also finally define the network, which is the app network. And then we need to bridge this network so that it will isolate the container networks from the host network. And the host network will be your server that the container will be running on it. So the driver here is a bridge network. So meaning that we are instructing Docker Compose to separate this network from the how do you call it, the host network. And so this network will be totally isolated from the host network. All right, so let's go over this. In some, let's say in a production environment, if you have your own MongoDB image, so you specify that image here. Maybe you are storing the image in any container registry. You need to specify the path here. And then also, if you are instead of building this whilst running the application, in some cases, if you are using a CI/CD pipeline to build your images, so you build your image and then just what, instead of build, you change this to image. So you can have an image here. So you specify the path to this image that will be pulled to run the container instances. In this instance, we are not specifying the image path, so we reverse to the build because we want to build the application locally. Okay. And the same thing goes to the front end as well. And so in some environment, okay, some applications like kind of have like a separate backend repository and then a separate front end repository. If you are defining this particular services using the Docker Compose, So you make sure that you define a Docker Compose for the dev environment, Docker Compose for staging environment, and then Docker Compose for production environment. That's if you are deploying your application on Docker Compose and it will be running on Docker, then you need to like define environment files for each of this. So you can have Docker compose dot, let's say, staging dot YAML. You can also have Docker compose dot prod. That's prod for production YAML. And so you define these files. So based on the environment that the code was triggered, you write a logic in your CI/CD pipeline that will reference these particular compose files based on what your environment or the environment you are pushing or deploying to. So let's say if you are deploying to the dev environment, you specify this file in your CI/CD pipeline. If you are deploying to your production staging environment, you will specify the staging file, compose file, and then if you are deploying to your production environment, then you will specify the production environment for a file. So in this instance, we are just deploying to just one environment, which is, we are not actually deploying, we are going to build for just one environment. So in this instance, we don't need this. We are going to delete this, but I'm just telling you this so that you know how to structure your Docker Compose file in case you need to like deploy application to different environments. So yeah, that's how you go about it. And also, if you have like a backend repository and then a front end repository, everything that we did here, so the backend needs to have its own Docker file, its own Docker compose file for various environments, that's staging, dev, and then production. And the same thing also goes to the, but because this is a monolithic application and it is a full stack application, we are just defining one Docker compose file that we use to build all these applications. So as you can see here, we've defined all our services. So when we deploy this, we are going to have like 3 containers created, one for Mongo, one for the backend, and then one for the front end. Now, all these Docker containers are going to share, communicate via a single network called the app network. So that's the network that we define for the application. All right. So now that we are done defining our Docker Compose file, we will now go ahead and then run the application. So let me initialize or launch a new terminal. Reduce this a little bit, and then we can cd into the compose file. So we need to cd into the compose file before we can run the commands. Okay, so let's list all the files that we have in. Why am I still typing A? So as you can see, we have the backend, we have the Docker Compose file, and then we have the front end file. So let me quickly run Docker. Let me clear the screen. First of all, let's make sure that our Docker desktop is running because we need to utilize Docker. So if you don't have Docker desktop installed on your machine, from the previous tutorials I mentioned that you can also install Docker on your machine. And if you don't want to install Docker, you can also have the Docker desktop. I think this is more convenient, so you can install this and use it. So let me just clear the screen, and then we can run our application. So Docker compose app. So this is the command to launch a compose service. Okay, when you are using Docker compose file, so use Docker compose app /d. So we are running this in a detached mode, so that when we close the terminal, we still have our containers running. You can also just do this and the containers will be built and everything. But once you close your terminal, all the containers will be destroyed, like I mentioned. So we run this in a detached mode and then hit enter. So let me move this up a bit. As you can see, our Mongo image is building and now it's being pulled. The image that we specify, which is this particular image, is being pulled. Let me move this down a bit. This is gonna take some time, but we would look at the processes. So as you can see, this image is being pulled, and once it's done pulling, it's gonna build the container, and then it will continue to the others as well. So once this is done, I'll come back and then we can take a look at. It's gonna take a while, so I wanna pause the video, and when this is done, we'll come back and then we'll go through the logs generated during the build process. Now, if you are trying this in your own environment, you will be able to look at all the processes. So, okay, so this is actually done. So you can see from here, from the top, our first image was pulled, and then also a finished building. And so these are the logs generated. So you can see, reading from the Docker SD, we have the backend internal load build definition Docker file. So you kind of like utilize all the files that we specify within the application containers. And then we also have the backend, pull the Nginx library, the Node 18 Alpine. Let's move on. So you can see the front end also get built, and then created some cache for the web directory. That's the application layers. And then it also exports the backend image. And now you can see the detailed report or the detailed log here. It says backend image has been pulled, image composed, the backend has been built. So both the backend and then the front end has been built. And then it also created the network for us, created a network, created a volume that we specify, which is this volume. This volume that we specify, this volume has been created to persist our data. And you can see all the three containers has been created as well. So we have the Mongo container has been created. The backend container has also been created, and then the front end container has also been created. And since we are running this in a detached mode, even if we close this terminal, our application will still be running. Now, I just want to change I just want us to see the two containers that has been created. The three containers that has been created. Let me close this because we have too many. Okay. It looks like we have too many terminals open. I wanted to move this side by side. Let me just see if I can remove this, kill the terminal. Also kill terminal. Let me kill this as well. So now we can create. So now I've divided the terminal into two. This is our application terminal when it was building. Now I want us to see the containers that has been created. So to see the containers, we can do docker ps. Let me close this a bit. So you can see we have container ID, container image, the command, the status of the container. So we have how many containers? One. So like one container is not running. Let me check this out. So in case you are not sure if a container is running or not running, you can use this command to see all the containers that has been created and see which one is not running. So this is the front end container which is running on port 8080. We have the backend container. It was created 4 minutes ago, but then it was exited. And the Mongoose container is also up. So we want to check why the backend container got exited. So let's look at, you can run this command docker logs and then paste this and see why the backend container got exited. So say server is running on port 3001, app modules, throw new error, unsupported option join is or are not supported. Mongo parser error option, okay, is not supported. There is an issue with our backend. I think there is an issue with our backend that we need to fix. So it kind of like breaking our backend. New user URL parser is not supported. We need to verify what we are doing wrong in our backend. So let's see. Mongoose.connect mongodb / mongo. Okay, so we miss out on, so the port number, we miss out on 7. Let's review this properly. So use new, so it's not user, it is use new URL parser. Spelling mistakes can sometimes break your application, so we need to verify this. So it says use new URL parser equal to true, and then use unified topologies also is equal to true. So I think basically that is it. And tags equal to mongo.model.tags, and then we specify the title, which is a string, completed, also boolean. I think aside that, everything else, so we have to rebuild our application after making these changes so that our front end container will run as expected. Okay, so we'll clear this side of the terminal and then do docker compose. So you want to destroy a container, you say docker compose down. And if you want to remove the volume that you created, then you specify this and run this to remove the volume. By this instance, we just want to start the service. We don't want to remove the volume that we created. So as soon as we run the docker compose down, it stopped and removed all the containers that we created. So if you do docker ps right now, you can see there are no containers what running. Now let's repeat the command, but this time around we are going to do docker compose up, and then we will run it in a detached mode so that the issue we had with our backend application breaking will fix that issue. So as you can see, we created the new containers after we made the changes. So now let's check if our backend container issue has been resolved. So docker ps, let's see. So this is running. It looks like something has still failed our backend. So let's check the logs again. First of all, let's check the status. So the backend has still exited 51 seconds ago. Let's check the logs again. So we clear the screen and then do docker logs and then paste and check what is wrong this time around. Unsupported option join. Are we having the same issue? Use new URL parser, parser. Let's see. Connection string. Okay. So port number is Mongo. What did he say? Load internal modules. Unsupported option join. Are we joining anything here? Let me see. Is there any issue from the front end? This. Okay, so let's remove the container volume, and this time around we'll remove the container volume and then rebuild and see what will happen. Okay, so everything is gone. Let's rebuild. Oh, sorry. Just need to specify detached mode. Okay, so container has been recreated, volumes has been recreated. Let's do docker ps. So our backend is still failing. Let me review what this issue is. It looks like there is something wrong with our connection. Let me just clear the screen and then rebuild the container again, and let's see what is actually happening. Docker compose down. Okay. We should have removed the volume as well. Okay, now I'm going to rebuild the container. Okay, so everything gets recreated again. From this screen, let me check the containers. So the backend has exited again. Let's see. So so it looks like the issue is coming from the MongoDB connection. So let me rebuild again. See why our container backend keeps failing. "15 seconds ago." Let me check the images created here. So the backend image has been created, all right, which it is in used, but then it's not stable. Okay. Okay, so the issue we're having was with how we are passing the user input. So it looks like that particular function is deprecated, and so it is no longer working. I need to refactor this code to be able to log the connection and then also catch any error that may persist. And then after that, I rebuilt the container, and it looks like now the backend container is running. So as you can see, let me clear the screen. Docker PS. So as you can see, the backend container is running as expected. So now we have the front end container, we have the backend container, and then we have the database, MongoDB database container, which has been up about a minute ago. So essentially, this is how you set up a Docker Compose file to be able to deploy multiple applications, application services, and that's containers. So if you are working in an organization where the company is not so heavy on Kubernetes, and it is also important that you can leverage the power of Docker Compose to deploy the application, to create like multiple services and deploy the application to onto the server. So you can also set up the CI/CD servers. You can set up CI/CD pipelines, and you'll be able to run these pipelines with these Docker files to deploy the application. So now we can go to our URL. So we can go to localhost port 8080. And so this is our application, Docker Task Manager. So let's create some tasks. Say, refactor code tomorrow. So let's create this task, create another task, meeting with infra manager, and then add that task, and then create another task, meeting with clients, and then finally one-on-one with line manager. All right, so these are all the tasks that we've created that we'll be doing, and all these tasks we'll be doing it tomorrow. Okay. All right. So now that we know what is happening, the next thing we are going to do is we are going to stop the container so that we can test our data persistence that we created here. Okay. So let's do Docker Compose down. So now our Docker Compose down has stopped and removed all our containers. If you go back to the app and reload the page, you see that say these sites cannot be reached. Local host refused to connect. So our containers are down. All the containers has been removed. Network has been removed. But then the data will still be what? Persisted. So let's bring up our containers, Docker Compose app, and run it in a detached mode. So the containers has been recreated. Let's go back and then reload the page. So as you can see, our application is back and running because the containers are up and running. And you see that all because of the database, data persistence, and the data volume that we created, our containers or our data is still intact. And you can see all the tags that we created. No tags has been lost because of the data persistence. And so that is Docker volumes working in action. And so I hope this video is of benefit to you and you've learned a lot. Please don't just watch the videos, but whilst you are watching the videos, you need to practice as well so that you can understand everything that I have talked about within this video. And like I mentioned, this is the last part of the container series. This is the previous videos that we created. This is the part 1. This is the part 2. So the part 3 will be uploaded for you to also watch. So if you haven't watched the part one and part two yet, kindly watch the part one and part two, and then you can come back and then continue watching the part two. And also do not forget to subscribe to the channel. I also have other videos that you can watch. For instance, if you want to get an internship in 2026, this is a video that I recommend you to watch. Looks like the network is lagging a bit. So yeah, but then I have a video when you go to the live, this was stream live. So in the live session, I have a video that I generally explain a lot about how you can get internship in 2026. So you can go and check out that video. So yeah, this is the video I'm talking about. You can go and watch that video and know all the strategies. I think this is the video. Sorry, I was looking at a different video rather. So you can go and watch this video and you will learn a lot from it. And also please subscribe to the channel and let's grow this channel together. Thank you and happy learning.